Humanoid robots are often accused of being impractical, but that doesn't stop researchers around the world from developing humanoid robots for all occasions. From avatar robots, construction robots, robotic assistants, domestic and research robots, entertainment robots, and the most advanced humanoid robots in the world in today's video. The most advanced robot avatars today are being developed in Japan. For example, the robot-HR3, introduced by Toyota in 2017. The humanoid robot is able to accurately imitate the movements of a human operator, including walking and fine finger movements. The 1.5 meter tall robot has 32 joints and is able to move very smoothly. The control is intuitive. The range of motion is not less than a human, and the VR helmet on the operator's head allows you to see through the eyes of the robot. The robot is designed to interact with people. The last update of the model was in 2019, but for now, unfortunately, it remains only a concept. Meltin is developing technology that would help create cyborgs in the future. These are processing biosignals through the nerves in the human body and developing robotic products that replicate the human anatomy. Now the company has 2 robotic avatars capable of accurately replicating human-like movements. It is MELTANT-A, which arms as precisely copy the structure of a human, taking into account the location of muscles and tendons going to individual fingers. Polymeric elastic wires are used as actuators, pressure sensors, and are also installed in the fingers of robots, and the feedback system provides haptic feedback. The robot is very accurate and very strong. It can hold a 2-liter canister of water with just 2 fingers. A signal transfer from the operator to the robot with a delay of only 0.02 of a second can even be done from a distance of 19,000 kilometers. And MELTANT-B, designed for interested customers for dangerous work in environments with high or low temperatures, with chemical, biological, or radioactive contamination, and even possibly for space exploration. In doing so, the robot can still communicate to humans, but not only with gripping force, but also with texture of the object. And then there's Model H, Teleexistence's robot avatar for shopping and remote travel in Japan. The robot is controlled by a HTC Vive virtual reality helmet and a pair of controllers. The robot itself is mounted on an autonomous wheeled platform, has a pair of arms and a rotatable head, which has 2 cameras for stereo vision. A development of the project was Model T robot-mercendazer, introduced last year. Store employees can control the robot, which acts as a merchandiser right from home using virtual reality. Video communication between the operator and the robot has a delay of 50 milliseconds, which has almost no effect on synchronicity. The robots are already working in stores of the Japanese chain Family Mart. Now, the company is working to make the robot work faster. But there are robots that are even closer to the human body. For example, PRO Robotics is developing and next year is going to mass produce a wearable robot called Guardian XO. The full-size exoskeleton is battery-powered and increases the operator's strength by 20 times, allowing you to lift loads up to 90 kilograms without strain. Guardian XO dynamically compensates for gravity and inertia, detecting the operator's movements within milliseconds. The suit's 24 degrees of freedom ensure free and natural movement, and the hands-free mode allows the operator to leave heavy loads in the hands of robot, freeing their own for demanding tasks. The robotic suit can be put on and removed in just 30 seconds without any assistance. The Guardian XO is the basis for the remotely controlled Guardian XT robot, which no longer needs to be put on itself. It is enough to control it from a safe distance. In the field of construction and repair, humanoid robots look attractive because they can work with the same materials and tools as humans. Take, for example, the HRP-5P robot, the 5th generation of robots from Japan's National Institute of Advanced Industrial Science and Technology. It can pick up and move heavy and bulky loads, open doors, go up and down stairs, bypass obstacles, and use common hand tools. The robot does not need constant supervision of the operator, and can perform a number of tasks independently, for example, move or fasten a sheet of drywall. The ARM-R6 robot from Secondhands Robotics, unlike the HRP-5P, is designed to help humans. The robot must understand commands in natural language and be able to recognize in advance what a human is trying to do and anticipate when it will need the help. In addition, the robot will be able to perform tasks that require a level of precision or physical strength that's unavailable to workers. And, of course, it must do all this autonomously and safely, surrounded by people in an active warehouse. The project is evolving, with the RMR-6 being tested at Okado's Technologies warehouse last year. Meanwhile, Kawada Robotics' NextAge Robots are already at work at the Glory Factory in Saitama, Japan. 19 robots work alongside 300 people assembling machines to sort money for cash registers. The humanoid robots are equipped with cameras in their hands and are capable of performing complex repetitive operations with superhuman power, speed, and accuracy. NextAge can be used without safety barriers, simply by placing it where humans used to work. What's more, multiple NextAge robots can coordinate their movements to work on the same task at the same time. Another helper robot, but now domestic, is the humanoid robot Walker from UBTECH Robotics. The company currently holds more than 700 patents in the humanoid robot industry. Walker is less than 1.5 meters tall and can recognize surfaces, map terrain, and avoid obstacles, walk on stairs, maintain balance under external influences, and manipulate various objects. It responds to voice, maintains eye contact, and can work safely alongside humans. 36 high-performance actuators, a full range of sensor systems, SLAM technology, and a system with elements of artificial intelligence allow this robot to recognize the host, find and track targets, as well as give an estimate of human posture, making the robot one of the most advanced robots in the world. Separately, research humanoid robots are worth highlighting in this issue. They don't yet solve specific tasks and are designed to allow engineers to understand what they can do in principle. The most famous and dexterous, of course, is the Atlas robot from Boston Dynamics. Contrary to popular fears, the robot is not equipped with artificial intelligence, but in dynamic movement, it is unrivaled. Cameras on its head, 28 joints in its legs and arms, and numerous sensors throughout the body help this robot stay in balance when making complex movements. When commanded to do a somersault, the robot relies on a developed library of movement trajectories, but adapts them to the real-world conditions in real time. We talked more about that at the link in the hint, and no, it's not computer graphics, as we're often told in the comments. But the 2020 breakthrough of the American Society of Mechanical Engineers recognized not Atlas, but the Iranian research humanoid Surena IV. The robot is capable of detecting faces and objects, recognizing and reproducing speech, and walking at a speed of less than 1 kilometer per hour. Surena has 43 degrees of freedom, and its arms can grasp objects in different shapes. Iranian engineers are using the robot to research two-legged movement, artificial intelligence, and to attract students to the engineering disciplines. If today's episode makes you think of Honda's Asimo robot, we mourn with you, because the project has closed and we will never see this robot again. What other advanced humanoid robots do you know? Let us know down in the comments. Subscribe to the Pro Robot channel while you're here, and like this video, and don't miss any new episodes from the world of high tech.